Welcome back. It's time to get some practice normalizing vectors. Now, we have 3 debug actors in our world, but I'd now like to just have one. So I'm going to use DA-loc1 and delete 2 and 3. I'm going to select them both in the outliner and delete them. Now, we know that our level blueprint is referencing them, but I can go ahead and click yes. Now, it's going to ask me this question multiple times because we have 2 things selected that violate this condition, but we can click apply to all and select yes, and that's going to allow us to delete those actors from our level. Now, we still have DA-loc1. It's right here. But if we go back and open our level blueprint, we're going to see now that we have a couple of unknowns because these actors don't exist. If we try to compile, we get those warnings, and the compiler results say that unknown is not referencing a valid level actor. We actually have 4 warnings. 2 of them we can see right here. But if we want to be taken to where a specific warning violation is occurring in the blueprint, well, each of these unknowns is a link. We can click on it, and we're going to focus in on that violation. And we can see that we're trying to use these references over here as well. These are also nodes referencing an actor that doesn't exist. Well, we're going to go ahead and delete all these nodes anyway. And we just want the reference to DA-loc1. So I didn't need to delete that one. I can actually Control Z to undo that deletion and take this DA-loc1. I can break the wire and set it off to the side because I want to keep using that. And I'm going to delete all the other nodes. So I still have DA-loc1. Now I can compile and we have no warnings. Now for this example, I'd like to have a couple of my drone actors because I want them to be in my level and I want them to constantly be moving towards my location 1 debug actor. We're going to learn how to make actors move. So let's get a couple of drone actors in here. Let's find our blueprints folder and get a BP drone and drag it in here. And I'm going to rename this one to BP drone _1. And that way, if I go ahead and duplicate it, we'll have a new one called BP drone 2. Now, I'm going to go ahead and move these up a little bit and take each one individually and rotate it so that it's kind of facing the direction of our debug actor. So I'm going to hit E and rotate it around. It doesn't have to be perfect. This is just for an example. We're going to just move them around. And what I want, my goal, is to press play and see those drones moving smoothly towards my debug actor, like they're chasing it, like they're enemies, right? And if I want to move an actor, I can add an offset to that actor. Let's learn how to add a world offset to an actor's location. To do that, I'm going to need a couple of references to these actors in my level blueprint. So I'm going to select BP drone 1 and come back to my level blueprint, right click and create a reference to BP drone 1. And I'd like a reference to BP drone 2 as well. So I'm going to select that one, come back and get a reference to that one as well. And what I'd like is to move these drones towards the location of DA-loc1. But before we can do that, we need to learn how to add a world offset to a specific actor. Let's start with BP drone 1. I'm going to move these nodes out of the way and get my BP drone 1 down here. And I'd like to add a world offset to my actor. So I'm going to drag off of BP drone 1, and there's a function that exists called add actor world offset. We're going to select that function. And here's what it looks like. It has an input execution pin, so we're going to have to connect that to something. I'm going to move event tick down just a bit. I'm not going to delete it because we're going to use it very soon. But I'm going to hook up add actor world offset to begin play. Now, add actor world offset takes in a number of inputs, but the only one we're concerned with for now is this one. It's a vector called delta location. And all it's going to do is move the actor by that vector. So with a value of 0, 0, 0, we're not going to move the actor at all. It's going to be moved by the vector 0, 0, 0. So let's take a look at BP drone 1. I'm going to select it here, and I'm just going to move it close to the origin here. I'm going to move it close for now, just so it's right here, very close, so we can get a reference point. We know that it's right here next to the debug actor, right? And we're going to add a world offset in begin play. Now, because I'm showing global space and not this actor's local space, right? This icon switches between that. If I have global space shown, I can see that the X direction is pointing that way into the distance there. And I'd like to add a world offset to this actor. I'd like to move it in the X direction. Well, let's say I'd like to move it in the X direction by 500 units. So what vector do we add to this actor's location to move it 500 units in the X? Well, that's going to be the vector with an X component of 500, and its Y and Z components will be 0. So let's just test that by hard coding in a delta location of 500, 0, 0. That's going to add a world offset to this drone 1 actor, and it's going to be 500 units in the X direction. So we see where it is. It's right there next to our debug actor. But if we press play, well, begin play has now been executed. And our actor has moved by 500 units in the X direction. Now, it's still drawing its debug coordinate system because, well, that was drawn in begin play in the actor. And we can remind ourselves by right-clicking on that drone actor and browsing to the asset, double-clicking it to open up BP drone, and we can see draw debug coordinate system is drawn once in begin play. So it's been drawn once in begin play. It's going to stick around for 60 seconds, and it's not going to move anywhere along with the actor, but we've seen that we can draw these in tick, right? So if we wanted to update this coordinate system every frame, we could do that by getting event tick. And we can hook up draw debug coordinate system to event tick instead of begin play. We can remove begin play. And if we're drawing this in tick, we want its duration to be 0 and not 60 seconds. That way we'll only draw it for a single frame, but we're drawing it over and over every frame. So now if we go ahead and play test, well, we've moved the actor forward in the X direction by 500, but we're still drawing that debug coordinate system at its current location every single frame. Okay, so now we've seen how we can add a world offset, and delta location determines what that offset will be. Let's say we'd like to move the actor 500 units up in the Z direction instead. Well, we can set the X of delta location to 0 and the Z to 500. And now if we play test, there's our actor. It's close to the ground, but if we press play and look up, there it is, 500 units up in the Z direction. And we can use literally any vector we want. If we want to move 500 units in the X and 500 units in the Z, well, we'd put a 500 right here in delta location's X component. And now we're going to move 500 units up and 500 units in the X direction. We can press play and see that it's 500 units up clearly, and it's also 500 units over in the X direction. So delta location here in add actor world offset has two important characteristics. It has a direction, but it also has a magnitude. And add actor world offset is something that we can do multiple times. We can do it over and over. In fact, we can do it in event tick if we want to. Let's see what happens if we do this in tick instead of begin play. I'm going to go ahead and connect this wire to event tick instead, and we're going to now add this offset every single frame. Now remember, frames occur very rapidly, so this delta location should actually be very, very small. It should have a smaller magnitude, right? So I'm going to set X to 1, Y and Z can both be 0. So every frame we're going to add an offset of delta location to the drone actor, but it's going to be 1 unit pointing in the X direction. Let's see what that looks like. Let's press play, and there it is. Every frame we're adding 1 unit, that's 1 centimeter in Unreal Engine, and we're adding that to our drone actor. It's moving in the X direction. And of course, you can have all kinds of fun with this. You can change that direction to move 1 unit in the y direction every frame, and we can see that now it's moving in the world's y direction, and it's doing so very smoothly because it's moving a small amount every single frame. So we've learned how to add a world offset, and we've seen that by doing this in tick with a very small value, we get smooth movement. Our actor is moving smoothly in a direction, and that direction is determined by delta location. But that wasn't exactly my goal for this video, was it? I wanted both of these drones to move towards the debug actor. So I need that delta location to point in that direction from each of these actors towards the debug actor here. Well, we know how to get the vector from one actor to another, right? That's pretty easy. We take the destination and subtract the starting point, and we get a vector from point A to B. So let's get the vector from drone 1 to DA Loc 1. We know how to do that, and we don't have to perform this calculation every frame. We can perform it once in begin play and cache that location. So I'm going to take BP drone 1, I'm going to duplicate it, I'm going to get actor location from it. So we have that location, and we also need DA Loc 1, so I'm going to get that actor reference. I'm going to call get actor location on that, and I'd like the vector from the drone to DA Loc 1. So I'm going to subtract, right? Vector subtraction, and I'm going to take the destination, that's the first vector. I'm going to drag off, hit minus, get a subtract node, and I'm going to subtract the starting point, that's the drone 1. And now we have the vector from the drone to DA Loc 1. And we're going to store this in a variable. Let's promote it to a variable. And by the way, speaking of variables, we're no longer using these two floats, so we can delete both of those. And we can promote this vector value to a variable, and I'm going to call this drone to loc. Loc short for Loc 1. We're going to store that vector in begin play. And this is the vector from drone 1 to Loc 1, so it's kind of a large value, right? We can't do this every tick because it's going to be too big of a vector. Let's just see what happens if we take drone to loc and stick it in for delta location here and go ahead and press play. What we're going to see is that it's going to look like the drone disappears because the very first frame is going to move this drone by that vector. The vector is from the drone to DA Loc 1. The very first frame, it's going to add that offset and set the drone's location right there at DA Loc 1, and then the next frame it's going to keep moving it in that direction, so it's going to be down below the floor, and before we know it, it's going to be very, very far away. So if we go ahead and play test this, I'm going to take my player start actually and move it over here and rotate it so it's facing what we're looking at and move it up here and press play. Well, the drone is gone. It's not this one, that's the other drone. Drone 1 is way down there, and it's still moving. In fact, we can shift F1 to get our mouse cursor and detach, and we can select drone 1, BP drone 1 here, and look at its location. There it's going. It's getting farther and farther away very rapidly. So we know that we can't just use the vector from the drone to the location. We need a smaller vector, but we want that vector pointing in the same direction. And that is where vector normalization comes in. You see, we have this case where we have a direction, but this vector is much too large. We want to make it smaller, so we're going to normalize the vector. So how do we normalize a vector? Well, we know how to do it mathematically. We could divide each component of the vector by its own magnitude, and we could do that manually with math nodes, but Unreal Engine has math utilities, right? And normalization is common enough that it deserves its own node. So we could take this drone to loc and we can normalize the vector. So we can take the value of drone to loc. We could either take it from here, from the set node, because it returns that value, or we could even take it from this subtraction node and normalize it first. Either way, we just need that vector value, and we can search for normalize. And there it is. It's called normalize. It's going to take a vector and return a new vector with a length of 1, but it's pointing in the same direction. Now, normalization requires some mathematical calculations, right? It takes the vector, it divides that vector by its own magnitude, and we get a tolerance. If we hover over tolerance, it says minimum squared vector length. So what this does, because there's a division involved, we're taking each component and dividing by the magnitude or length of the vector. Well, if that vector has a really, really small length, or even 0, well, we don't want to divide by a very small value, because dividing by a small value results in a very large value, and dividing by 0 is undefined. So if the vector we're passing in here has too small of a length, say lower than this tolerance, well, then this node is just going to give us a 0 vector with zeros in all x, y, and z components. We don't have to worry about that because we know this vector doesn't have a length of 0. So instead of setting our drone to loc vector to the result of the vector subtraction, we can set it to the result of the normalize operation. And now we know this vector will be normalized, and we can prove that by seeing that add actor world offset using this vector is going to have different behavior now. Let's see what that behavior looks like by pressing play. And there it is. It's moving very slow, 1 unit every frame. And it's moving towards that debug actor. Now notice it kept going, right? It didn't stop because that vector was calculated once in begin play. And so that's the value that it's using for the actor world offset. We'll see that it continues moving and it never stops. But that's okay. This is just for a simple example. We just want the vector from the drone to this location, and we've normalized it so it's smaller. And the cool thing about this is that because we normalized it, we can scale that vector to make it larger or smaller. We can always take a vector and scale it by multiplying it by a scalar value, a floating point number. We can do that by dragging off of the vector. We can use the asterisk symbol that gives us the multiply node, and we can multiply two vectors. Now, multiplying a vector by a scalar value requires that we pass in a scalar value, a float. But the multiply node takes in two vectors. Well, that's okay. These pins can be changed. We can take that second input pin and right-click, and we can use the pin conversions. And we can convert this to a float. Now, there's a float single precision and a float double precision, and we'll talk about the differences later on. Let's just choose to float single precision, and now we have the ability to scale this vector by a value. Let's say we want it to be twice as long. We can put a 2 in here. And now the vector returned by this multiplication node is no longer a unit vector. It's actually twice as long. It's going to have a length of 2. And if we're adding a world offset using a larger vector, a vector with a length of 2, well, that drone's going to move twice as fast now. And if we press play, we can see that it's moving faster. And we can set this to a way higher number, such as 10, and it's going to move 10 times faster. There it goes. So that's the usefulness of normalizing vectors. I'm going to set that back to 2, so it's only scaled by 2. And we're going to go ahead and do the same thing for our second drone. So we're going to have two drone to loc vectors. I'm going to rename drone to loc so that it's called drone 1 to loc. And I'm going to have a second one that's going to be drone 2 to loc. And really, I can just reuse these nodes here. I'm going to duplicate them over here, Control D. The only difference is I don't want the vector from drone 1 to loc 1. I want the vector from drone 2 to loc 1. So I'm going to take this drone 1 actor reference and delete it, and take my BP drone 2 actor reference and hook that one in instead. So now we're getting the vector from drone 2 to loc 1. We're normalizing it, and we're going to store that in a new variable by promoting this to a variable, and we're going to call this drone 2 to loc. So now we have two vectors that we can use, and we can add a world offset to both drone 1 and drone 2. So I'm going to take add actor world offset and duplicate that node, and I'm going to take drone 2, that actor reference, and duplicate that one. and that's going to go into the target because add actor world offset needs to know which actor to add a world offset to. And for delta location, we're going to take drone 2 to loc, and we're going to get it. Now, at this point, I think you're ready for another shortcut. I need a get node, right? And I know I can drag out and click on get to get a get node and hook that in. We also know about the shortcut where we can drag a value straight into a pin and we can get a get node that way that's already connected. Now, another shortcut is using Control and Alt. If I hold Control and drag a value in, I automatically get a get node. And if I hold Alt and drag it in, I automatically get a set node. So Control and Alt are additional shortcuts we can use. And a good way to remember is that if you just drag it in normally, get is first and set is second. And if you look at your keyboard, Control is the first one, it's to the left, and Alt is the second one. So the first one is Control, that's for get. The second one is Alt, that's for set. And that can get us those nodes more quickly. So that's just another shortcut. So I want to get drone 2 to loc. So I'm going to hold Control and click and drag it in to get a get node. And we're going to use vector multiplication. So I'm going to drag off, type the asterisk, get a multiply node. I'm going to convert that second pin to a float input type. And I'm going to scale this second drone's speed by scaling this vector to a value of 0.25. It's going to be smaller than a unit vector. It's going to have a length of 0.25. So we're only going to add a world offset with that smaller offset this time. That's for drone 2. So what we should see is our first drone will move towards DA loc 1 with a speed of 2 units per frame, and our second drone is going to move with a speed of 0.25 units per frame. It's going to be very small. Let's see what this looks like. There we go. That one's going faster, and the other drone is moving much, much slower. And we were able to do that because we normalized the vectors between these actors. And then we could scale them however we wanted when we wanted to use them, such as by adding an actor world offset. So that's a really nice example of why we may want to normalize a vector and even scale the vector. And we also learn how we can add an actor world offset, which is really nice because we're now able to see our actors moving in the world. Now, we're not rotating the actors. In fact, if I rotate this drone so that it's facing that way, well, now we see that it's moving backwards because we're never actually adjusting its rotation. All we're doing is moving it in space. We're translating it every frame. So that just shows us that add actor world offset really has nothing to do with the actor's rotation at all. It's only going to add the offset to that actor by simply adding a vector to that actor. So excellent job. We now have practice normalizing vectors, even scaling them, and using add actor world offset. We're adding that offset every frame in tick. Awesome job, and I'll see you soon.